This is 8.1 Basic of Statistics, question 3 and 4. Identify the hypothesis testing as being two-tailed. For two-tailed test means that it's not equal. That means your claim will say it is either equal or not equal. For left-tailed test means you have to use less than. That means your alternative hypothesis will be less than. And for a right-tailed test, you will be using greater than. And then once you figure out are they left or right tails, you have to find the critical value and the p-value, and then you have to make a decision based on alpha. The significant level is 0.05. So question 3 is asking that the test statistic of z equals to 2 is obtained when testing the claim p is greater than 0.05. Now since the claim is given us is p is greater than 0.05, this is going to be a right-tailed test. Now, in order for us to find the critical value, you have to refer back to the table here. This is how you figure out the critical value. The two-tailed test, left-tailed test, right-tailed test, is that proportion or is that mean? Now, since based on this question, we know this is a right-tailed test, and it is a proportion. And how do we know it's proportion? Is because the claim is using p instead of mu. Okay, so for this case, since it is a proportion and it is a right-tailed test, so your critical value z alpha in this case will be q norm of 1 minus alpha, and alpha in this case is your 5%, since that is your significant value in this case, and your answer in this case is always positive. So in order for us to find the critical value, it is actually q norm 1 minus alpha, and alpha in this case is 0.05. And if you type this in your R, q norm of this will give us 1.645. Now we need to find the p-value. Now in order for us to find the p-value, you also have to use the notes down here. So in order for us to find the p-value, you have to figure out are they left, right, or two tails. And this is a right tail since it is great. We have it for greater than. Then you have to use 1 minus p norm z for proportion, or 1 minus ptt and minus 1 for mean. So since we are having proportion, so in order for us to find the p-value is going to be 1 minus p norm z. Now what is z in this case? The z in this case is provided to us in the question, which is 2 in this case. So you just need to figure out what is 1 minus p norm of 2. And again, if you use this to copy and paste into your R here, 1 minus p norm of 2 is actually 0.022778. So that is the p-value in this case. Lastly, you have to figure out what is the decision based on the alpha is 0.05. And how do we make our decision is again right on number 5 here. This is how we make decision. If your p-value is less than or equals to alpha, we will reject the null hypothesis. If your p-value is greater than alpha, we will fail to reject the null hypothesis. So now what you need to know is look at the p-value that you have. Our p-value in this case is 0.0228, and our alpha, our significant value is 0.05, and we know that 0.0228 is less than 0.05. So based on the table, if it's less than, then we will make a decision saying that we will be rejecting the null hypothesis in this case. So your decision in this case is we will be rejecting the null hypothesis in this case. Now for question number 4, we will be using H1 is p is not equals to 2/3. This is your alternative hypothesis, and the test statistics is 2.5. So again, is this a left, right, or two-tail? Since there is a not equal sign, so this is going to be a two-tail test in this case. Next, you need to find the critical value. Now, since it's a two-tailed test, and this is also proportion because the P is used here. So if you look back at the table, for population proportion for two-tailed test, the critical value is Q norm 1 minus alpha over 2. So in order for us to find the critical value in this case, it's going to be Q norm 1 minus alpha. Again, alpha in this case is 0.05 over 2. And if you use your R to figure this critical value, this critical value came out to be 1.96. Next, you have to find the p-value. So in order for you to figure out the p-value, again, we refer back to your notes. Since this is a two-tailed test, in order for you to find a p-value, you have to take the twice of this test statistics. And how do we figure out is you have to figure out what is your p-value in this case. So if you look at this, the z-score that we have is a 2.5, which is positive. So that means it's telling us that we're going to use the critical value for the right tail because our z is positive. If your z is negative, then we will use the left tail. And since this is a proportion, we'll be using also 1 minus p norm z in this case. So for R in this case, in order for you to find the p-value is you have to find 1 minus p norm z. And again, the z in this case is 2.5, which is given us by this value. So when you copy and paste this into your R, so this is how we find out this. Your answer in this case is 0.0062. But this answer is wrong. The reason why is because this is a two-tailed test. And for two-tailed test, you have to take twice of this area. So in this case, you need to multiply this by 2. So if you take p norm 2.5, which is 0.0062, and then 1 times 2, so your answer for p-value in this case is 0.01242. And finally, we have to make our decision. This decision is based on the p-value that you found, which is 0.01242, and the alpha, which is 0.05. Again, we use 0.05 in alpha here. And again, since our p-value is less than alpha, which is exactly what we have in 3, so our decision in this case will be rejecting the null hypothesis. Now, do not forget, class, this is very important for chapter 8, 9, 11, 12, and p-value here will be less than alpha, will be reject the null. P-value greater than alpha is we fail to reject the null. We never use the word accept the null. The reason why we never use the word accept instead of accepting here is because that we still have that 5% error. This is your error here. So that's the reason why that we will not use accepting the null hypothesis. We use the word fail to reject the null hypothesis.